Welcome back to the Deep Dive. Today we're plunging into, well, a really foundational topic now, blockchain.
Yeah, it's gone from this niche thing to something really underpinning a lot of new tech.
Absolutely. We've gathered quite a bit of material, and our goal today is to, cut through the hype and the jargon.
Mm.
We want to give you a solid, clear picture of what blockchain actually is, how it works, and crucially, why it matters so much more than maybe you first thought.
Right. It often gets buried in technical details, doesn't it?
Yeah.
But the core idea is, well, it's quite elegant, really. It's about creating trust and managing data without needing one central boss, like a bank.
That's a great way to put it, the trust aspect.
Yeah, for me, that's the key innovation.
So let's start right there. At its heart, blockchain is a digital ledger. But the key difference is it's decentralized and distributed,
Exactly. Not one company holding the books.
right? Instead, this ledger, this record book, is copied and spread across a whole network of computers. We call them nodes.
And that distribution is what gives it its strength.
Mhm.
Transparency, security, resilience, they're sort of built in from the start because everyone has a copy.
Okay, so that sharing makes it transparent. But what does that really change compared to, say, my bank's database?
Well, think about it. With your bank, you trust the institution. You trust them not to mess up the records or get hacked badly.
Uh-huh.
With blockchain, you're shifting that trust. You're not trusting a single company. You're trusting the network and the math, the cryptography behind it.
So less trust in people, more in the system itself.
Precisely. And because there's no single central point, there's no single point of failure. No one place for hackers to target or for, say, a government to easily censor. It's much tougher to take down or manipulate.
Okay, that distinction, centralized versus decentralized, is huge. So how does this shared ledger actually function? Let's get into the nuts and bolts.
Right. So information isn't just thrown in randomly. It's grouped into batches into these called blocks.
The blocks.
Each block holds a bunch of transactions, like records of payments, plus a timestamp showing when it was created, and a unique code, a cryptographic hash. Think of it like a digital fingerprint for that specific block.
A fingerprint, got it.
And here's the really clever part of the chain. Each new block doesn't just have its own fingerprint. Its fingerprint is also created using the fingerprint of the block that came before it.
Ah, so they're linked cryptographically.
Exactly. It creates this chain, one block after another, chronologically. And because each block's identity depends on the previous one, you can't change an old block without breaking the chain.
It sounds tamper evident then.
Highly tamper evident. It's like digital sealing wax on every single link.
So if someone, maybe someone with a lot of computing power, did try to go back and change old data, how hard is that, really? Is it truly immutable?
For any established blockchain like Bitcoin or Ethereum, it's practically impossible. It's not just changing the data in one block.
Right, you said it breaks the chain.
You'd have to recalculate the hash, the fingerprint for that block, and for every single block that came after it, because they all depend on the previous one.
Okay, that sounds computationally massive.
It is. And you'd have to do all that recalculation faster than the entire rest of the network is adding new legitimate blocks. And then you'd somehow need to convince most of the network nodes that your fake chain is the real one.
Oh, yeah.
The energy and computing power needed are just astronomical. So yeah, for all practical purposes, the records are immutable and incredibly trustworthy.
That makes sense. So you have all these copies, these nodes. How do they all agree on what's valid, before a new block gets added? There must be rules.
There are. That's where consensus mechanisms come in. They're the rule book for
Mhm.
how the network reaches agreement.
Right.
The most famous one, especially because of Bitcoin, is proof of work, POW.
Proof of work. Heard of it. How does that work?
So with POW, specialized nodes, called miners, are all competing. They're trying to solve a really complex mathematical puzzle.
Like a race.
Exactly, a global computational race. The first miner to find the solution gets to add the next block to the chain, and they get rewarded, usually with some of the cryptocurrency.
Okay, but that sounds like it uses a ton of energy, that puzzle-solving competition. Is that the big criticism?
That's absolutely the main criticism of proof of work. The energy consumption is significant, and it's a real environmental concern,
Yeah.
which is exactly why other methods have been developed. A really popular alternative now is proof of stake, or PAS.
Proof of stake. Different approach.
Totally different. Instead of miners racing to solve puzzles, you have validators. These validators are chosen to create new blocks based on how much cryptocurrency they stake, basically, how much they lock up as collateral.
Ah, so they have skin in the game.
Exactly. If they try to cheat or validate bad transactions, they risk losing their staked coins. So it incentivizes good behavior through economics, not just raw computing power.
And that's more energy efficient.
Significantly more, orders of magnitude less energy intensive than proof of work.
Are there others besides those two main ones?
Oh, yeah. There are variations like delegated proof of stake, where people vote for delegates who then do the validating, and others like Byzantine fault tolerance, which are designed to handle some nodes being unreliable or even malicious.
Okay.
But the core goal is always the same. Get the network to agree on the valid state of the ledger without a central authority, prevent fraud like spending the same money twice, and ensure everyone has the same correct version of the chain.
And because everyone has a copy, it's all transparent.
Completely transparent. Every valid transaction is there for anyone on the network to see and audit.
Okay, let's make this super concrete. Walk us through a simple transaction. Say, I want to send you some crypto. What are the steps?
Okay, so step 1, you use your digital wallet to create the transaction request. Send X amount to this address.
Right. Click send.
That request then gets broadcast out to the whole network, to all the nodes.
Okay, it's out there. Now what?
The nodes, miners or validators, depending on the system, pick up your transaction. They check it. Do you actually have the funds? Is the transaction format correct? Does it follow all the rules? This is the validation part, using that consensus mechanism we talked about.
Got it. Checking the legitimacy.
Once enough nodes agree it's valid, your transaction gets bundled together with other recently validated transactions into a new block.
The next block in the chain.
Exactly. And the node building that block calculates its hash, making sure to include the hash of the previous block, locking it into place.
And then it's official.
Almost. The final step is reaching network consensus on that new block. Once, say, the proof of work puzzle is solved or the proof of stake validator is chosen and confirms it, the block is officially added to the end of the chain.
And then it's done.
Then it's done. Every node updates its copy of the blockchain to include this new block. Your transaction is now permanent, immutable, visible to everyone. No takebacks. That's a really clear process.
Yeah.
Okay, so we have this secure, transparent, decentralized ledger technology. Why should the average person care beyond, Bitcoin speculation? What's the big deal?
Well, it boils down to a few key benefits. First, security. We've touched on this, but the combination of cryptography and decentralization makes these systems incredibly hard to hack or defraud compared to traditional databases.
Right, the computational cost.
Yeah. Then there's trust. And this is profound. Blockchain allows people or companies who don't know or trust each other to transact and collaborate directly because they can trust the protocol itself. The shared, unchangeable ledger acts as the source of truth.
Removing the need for a trusted middleman in many cases.
Exactly, which leads right into efficiency. Think about processes like international payments or tracking goods in a supply chain. Normally, you have lots of intermediaries, lots of reconciliation between different companies' records. It's slow and expensive.
Blockchain can automate a lot of that verification and settlement. Because everyone's looking at the same ledger, you cut out huge amounts of friction, saving time and money. It's not always faster transaction speed, but the overall process efficiency can be dramatically better.
That's a really interesting point about reconciliation costs.
Yeah.
Okay, and the last big piece, programmability. This is where smart contracts come in, right?
Yeah.
What exactly are they?
Right. Smart contracts are basically just computer programs stored on the blockchain that automatically run when certain conditions are met.
Like an if-then statement, but on the blockchain.
Sort of, yeah. But a very secure and automated one. Imagine an insurance contract that automatically pays out a claim if a verified weather data feed reports a hurricane hitting a certain area.
No need for adjusters or paperwork in that specific case.
Potentially, yes. Or think about automatically releasing funds held in escrow once a shipping tracker confirms delivery. They execute the terms of an agreement automatically and enforceably without needing lawyers or banks to oversee it.
Okay, that opens up a lot of possibilities beyond just currency.
The huge possibilities.
Let's talk about some of those real-world uses then, maybe some that would surprise people.
Sure. We mentioned finance. Cross-border payments are a big one, much faster and cheaper than the old correspondent banking system.
Right. And supply chain management.
Yeah, tracking goods from farm to table or factory to store shelf. You get this transparent, verifiable record. It helps fight counterfeiting, proves authenticity, even verifies ethical sourcing. That's huge for consumer trust.
I can see that. What about something like healthcare?
Securing patient records,
Hmm.
making them tamper-proof, but also allowing controlled access for different doctors or hospitals with the patient's permission, all recorded transparently on the chain. It improves data integrity and potentially patient control.
Okay. And real estate. That seems like a paperwork nightmare usually.
Exactly. Blockchain could streamline property title transfers. Imagine reducing weeks of closing processes down to days or even hours with an immutable digital record of ownership.
That would be transformative.
Definitely. And think about voting. Digital voting systems built on blockchain could offer much greater transparency and resistance to tampering, potentially increasing trust in elections.
That's a big claim, but the potential is there.
The potential, yes. And digital identity, too. Instead of companies holding your data, you could have a self-sovereign identity verified on a blockchain, giving you control over who sees your information. Could be a powerful tool against identity theft.
Wow. And finally, entertainment. We hear about NFTs.
Right. Non-fungible tokens. They use blockchain to prove ownership of unique digital items, art, music, collectibles, virtual land. It's creating entirely new markets and ways for creators to monetize their work directly.
So it really does stretch across many, many industries.
Absolutely. The common thread is usually situations where trust, transparency, or efficiency across multiple parties is paramount.
Okay, but it's not all perfect, right? There must be challenges.
Yeah.
What are the big hurdles blockchain faces now?
Oh, definitely. Scalability is a major one. Some of the most popular blockchains, especially older ones, can get really congested.
Like a traffic jam.
Exactly. Too many transactions trying to get processed, which leads to slow confirmation times and high transaction fees. That makes it impractical for, say, buying a coffee.
Right. Not ideal for everyday use yet.
Then there's the energy consumption issue we talked about with proof of work. It's a serious environmental concern that the industry is actively working on with things like proof of stake, but it's still a factor.
Mm-hmm.
And finally, regulation. Governments worldwide are still figuring out how to approach blockchain and crypto. This uncertainty can make businesses hesitant to adopt the technology or innovate too quickly. It's a complex legal landscape that's constantly shifting.
So scalability, energy, regulation, significant challenges. But it sounds like there's also a lot of work being done to address them.
Absolutely. There's constant innovation in developing faster, more efficient consensus mechanisms, and layer 2 solutions designed to handle transactions off the main chain to improve speed and reduce costs.
So looking forward, despite the hurdles, what's the overall trajectory? Where's this heading?
I think the potential remains enormous. As these technologies mature, as scalability improves, as regulation becomes clearer, I expect we'll see blockchain become much more deeply integrated into the background of our digital lives.
Maybe in ways we don't even notice directly.
Very possibly. It could become part of the underlying infrastructure for everything from finance and logistics to digital identity and online interactions. It points towards a future digital economy that's potentially more transparent, more efficient, and relies less on traditional intermediaries.
So here's a final thought for you, our listener, to chew on. As this technology matures and starts overcoming these hurdles we've discussed, how might it fundamentally change interactions you take for granted right now? Think about how you prove who you are online, how you vote, how you buy or sell things, even how you own digital stuff like music or art. Could we be moving towards a world where trust isn't just assumed, but it's actually built in, cryptographically proven by the systems we use every day? Something to consider.
A very different digital world, potentially.
Indeed. Well, thank you for diving deep with us today into the world of blockchain.